Hello and welcome to lesson 4 in the topic of resources and energy resource management. This session is going to be looking at the global consumption of resources. So by the end of this session, you need to know the global patterns of usage and consumption of 3 particular resources: food, energy and water. 3 absolutely vital ones for life. Understand the reasons why the consumption of resources is uneven. Some places use far more food, energy and water than others. And recognise patterns and trends from maps and data. So a bit of geographical skill work as well, which we've already done a bit of in this topic already. So get the title written down and the learning objectives, and then when you're ready, we'll carry on. So just to recap the last session, which was looking at the national distribution of resources, so where certain resources are spread around the UK. I want to see what you can remember, so don't necessarily look in your notes straight away, about where some of our resources are found. So 1 to 5 here, the question's 1 to 5, or the statement's 1 to 5, there is a missing word. You do not have to write this down, you've got it all in your notes, but what I'd like you to do is try and recognise from memory what the missing word is. Okay, so pause the screen, read them through and see if you can work out what the missing word is, and then when you're ready, unpause the screen and I'll reveal the answers. Okay, so nowadays Scotland produces the largest amount of coal in the UK. Today, iron is most commonly mined in the Wealds of South England and the areas around St Austell and Brendan Hills. Oil and gas from the North Sea are important but declining sources of energy. One of the most productive arable areas is East Anglia, where potatoes, cereals and vegetables are grown in fertile soils, helped by warm summers and generally flat land. And water resources are more plentiful in some parts of the UK, particularly in the north and west, where annual rainfall is high and population density is low or lower. Okay, hopefully you've got that as a sort of a recap from your notes, and now we're going to go on to the consumption of resources globally. So the global patterns of consumption essentially are uneven. We've already mentioned that, and we're going to be looking at this in general. Now this lesson involves you getting onto Office 365 into the JogVlogs folder to get some map resources, but additionally there's going to be quite a bit of note taking from this session. So I'll kind of talk you through the notes and then pause the screen whenever you need to, just to make sure you've got them in your book. So the 3 things that we're looking at with regards to this session are really the 3 essential resources for life, for human life, and that is food, it's water and it's energy. We use all of those 3 things in order really to survive and thrive. When it comes to developed countries like the UK, like the USA, like Canada, Japan, wherever, we are actually consuming on average about 10 times more natural resources than those in developing countries. So, you know, someone in London is consuming 10 times potentially more energy and water and food for their entire life. Okay, think about all the water that goes into growing crops, all that sort of stuff, washing cars, using dishwashers. 10 times more resources than someone may be living in Sierra Leone, for example. So there is a big difference between the actual consumption of resources. Now that's not us being particularly wasteful, it's just because it's a variety of reasons really. We have a lot of available energy, we're a wealthy nation, we've got more products, and so with development comes more consumption of resources. So actually, you know, we know that a lot of resources we've got are finite. They, you know, potentially could run out, or we could run out of space to grow crops, or we could run out of fresh water to use. So as the world develops, as every nation kind of gets wealthier and becomes more developed, that pattern of consumption is only going to go up, and we need to really consider that as something that's a concern going forward. So again, I've got a couple of stats for you to write these down as well. Someone who lives in North America, so USA and Canada, mainly the USA, consumes around 90 kilos of resources a day, whereas someone living in an African nation, on average, consumes about 10 kilos of resources a day. And things like rapid development, which we've mentioned a little bit, and it ties in quite nicely to the topic of development as well, looking at India and their increase in consumption of resources. and the standard of living. So China, India, Brazil, all countries which we'd class as kind of emerging or developing nations where they're really industrializing. And as a result of that, their rate of global consumption of resources is skyrocketing. And that's, again, not their fault. We can't just say, from a UK perspective, oh, you guys, you need to slow down what you're using, because we already use far more than they do per capita, per person. So here we go. Here's some stats for you. Please write them down and some information. This will be a kind of a good introductory section to your notes. So pause the screen, get those written down. When you're ready, unpause. So we're going to start by looking at energy consumption, because remember the three we looked at were water, food and energy. And we'll start with energy, and what we will actually go on to in the latter part of this topic, which is starting next lesson specifically, is we're going to focus on energy quite a lot. So this is going to be a bit of preemptive general overview about global energy consumption before the next few lessons are going to talk a bit more about energy in detail. So energy is influenced by a few key factors, and one of the main factors is, does that place have energy resources? And that the age-old energy resource that we use through the Industrial Revolution, and lots of nations are still relying on for things like their power stations, is fossil fuel reserves. So coal, oil, natural gas, if you have those within your country and you have the ability to get at them, then you will use them. But also, looking more kind of modern scale, if you have a lot of sun, like if you are a nation near the equator or within the tropics, you have the potential to harness lots of solar energy, whereas in the UK we don't have quite the same level of potential because of our position on the world. But we do in the UK have lots of wind energy. We're an island in the middle of we've got the Atlantic to the left, or to the west, sorry, and the North Sea to the east. So we are surrounded by areas that can generate quite high amounts of wind. So that's a factor as well. If the resources are available, that will determine how many resources you can use. Iceland, use a lot of geothermal power, because they're essentially an island created through volcanoes, through volcanism. So they have that resource ready for them, but we don't have that same level of resource. We've got no active volcanic active areas in the UK, so geothermal energy is not really something that we can harness. So places where coal and oil reserves are predominantly found, and we have seen this in a previous lesson actually with the global distribution of resources, that world map that you looked at. But places like the Middle East, they have a lot of things like oil reserves and coal in places like India, whatever. But in the Middle East, there is another factor that makes a difference to energy consumption, and that's because the Middle East have got some instability when it comes to their governance. It doesn't mean that they're always unstable, but it does mean that they are a place where it's not just a straightforward supply of energy from them to other nations around the world, because people are fighting for control of those resources, and inevitably that disrupts the flow. We've talked about renewables already slightly, and so the amount of sunlight you have or the amount of wind you receive will determine whether you can actually use this type of energy. And then another big one, this has got, again, loads of stats in it, so I'll talk you through them, and then I'll give you a chance, or you can pause the screen to write down to make sure you've got your notes. So it's estimated that global energy consumption will increase by 56% in the next 35 years. Now, in the last slide, we looked at the fact that Brazil and India and China are all rapidly developing, and other nations are going to follow suit. And as a result of that rapid development, energy production and energy consumption increases as well. And actually, the projection is currently that it will increase by 56%. So that's half of what we use currently added on to what we use currently. It's a huge amount. And China and India, the development of those two nations in particular, and their combined population of over 2.5 billion people, is going to be something where that really is going to be felt the most. So Asia's energy consumption has risen, and then just sort of to illustrate this, from the year 2000 it was 2,931 millions of tons of oil equivalent, I'll explain that in a second, to 5,545 millions of tons of oil equivalent just 14 years later. So effectively the consumption of energy doubled pretty much in the space of 14 years just from that continent, just from Asia. So millions of tons of oil equivalent, just so we've got an explanation, is it's like the standard currency, I suppose you'd say, or standard unit of measurement when we look at energy. Because energy doesn't just come from oil, it comes from coal, it comes from gas, it comes from solar, wind, geothermal, all those things. But to compare energy, you need to have a similar unit. Very much like when we compare currencies of countries, we don't say, oh, well, the UK made 400 trillion pounds, whereas the USA made 500 trillion dollars, because they don't compare. You know, a dollar is not worth the same as a pound. So the global currency we use to compare countries needs to be the same, like the dollar. So if, you know, we said that this thing is worth $7 and this thing is worth $15, we know that one is worth 15, the other worth 7. But if we said this is worth $7, this is worth £8, it's harder to tell which one is actually worth more. So MTOE, or millions of tons of oil equivalent, is just that currency. It's just the way we compare use of energy. So on to the first map. Sorry, and if you need to go back to finish that slide off, please do. You can pause the screen, utilise the fact this is a video and you're not in class time. So this map you need, and if you haven't got it on 365, take a screenshot, is absolutely fine, but try and answer those 2 questions, okay? Pretty standard questions, and then they shouldn't take you too long, but I just want to interpret the resource and answer those 2 questions. So pause the screen and have a little go at them, please. Okay, so the first question says, state the 5 countries with the highest millions of tons of oil equivalent in 2016, and that's what this map is. It's a map that shows the global energy consumption in 2016. And I wouldn't even look at the map here, because that, you know, if I'm not good at my countries, I wouldn't know. I mean, I can spot that the USA is the darkest colour, and that's above 1,000. So USA, you've got Russia, you've got China, but you've actually got a table here that tells you. So the top 5 are China, United States, Russia, Saudi Arabia, and India. So they are your answers there. The second question, which continent has the lowest amount of energy consumption? Well, you're looking at the continent that is the lightest, and clearly the majority of Africa is below 50 MTOE. So Africa is the answer there. That's the continent. So moving on to the next question. Hopefully you got that right. Calculate the difference. Again, some good exam practice skills here, because you will get questions like this. They'll give you a resource with numbers on it, with trends on it, with patterns on it. You will be expected to be able to get the answers from there quite quickly. So calculate the difference in energy consumption between the largest energy consumer, which is China, and the 10th largest, which is Brazil. So just calculate the difference between Brazil and China. Pause the screen to do that. It should only take you about 20 seconds. Okay, so the answer here is 2,538 MTOE minus 287 MTOE, and therefore it's 2,251 MTOE. That's what you should have got. Pretty standard. Don't get much harder than that when it comes to maths and geography, so hopefully that should be bread and butter to many of you. Okay, so moving on. We've looked at energy, and we've given a good overview of energy and how energy consumption varies around the world. And we've seen from this map the countries which use the most energy. When it comes to food, okay, we're going to have a little look at and compare this. So again, just like with energy, there's a page of information around food consumption globally. Then we're going to have a little map skills task. So the richest countries, such as the USA, consume more calories per day than some of the poorest countries like Ghana. That might not be a huge shock to many of you. In some parts of Africa, the average food consumption of less than 2,000 calories per day is leading to undernourishment and undernutrition. So people do not have enough calories, but they also don't have enough nutrients. Okay, that's what those 2 things mean. Undernourishment is not having enough calories for energy, and undernutrition is not having enough certain types of nutrients. So for example, if you ate chips every day, you're not undernourished, but you certainly are undernutritioned. That's not a word. I don't know what the equivalent is. There we go. But you don't have enough vitamins, basically, because you're only eating deep-fried potato. The world has the ability to feed all of its inhabitants. We do have hope, but this does not happen because of greed. How many times have we gone to a place like Cosmo or an all-you-can-eat and left stuff on our plate and chucked it away? Now again, this is not our fault. We are not going to stick it in an envelope and send it to the poor people of Ghana. That's unrealistic, and it's gross. But it is something where, culturally speaking, we overeat. At Christmas, we eat far more than we need, and we should, because we can. And that's really the purpose behind it. Whereas some places don't have a Christmas dinner that's gut busting, sorry, not butt gusting. That's something that happens with too many sprouts, butt gusts. In poorer countries, focus, Mr. Halls. The uneven distribution in poorer countries can be because they can't grow enough food. They haven't got the supply, and they also don't have the money to buy it in and import food. And so the problems we have don't just stretch to the undernourished places in African nations, for example, but obesity as well. And obesity, the UK is the fattest nation in Europe. I think statistically, I think the USA is still probably, quite by some way, the fattest nation on the planet, and that's because we just have so much access to food, whereas some people suffer with famine, and they're dying in their droves because of it. So again, pause the screen to get these notes down, and then we're going to have a map skills task from either the screenshot that you're going to take on the next slide, or from what you've saved from the Joglogs folder on Office 365. So here you go, figure 2. This is a map to show the percentage of the world's population who are undernourished, do not have enough calories. So have a little look at this map and try and answer those two questions. Excuse me, I'm so sorry about that. Okay, so looking at this, the average percentage of people undernourished in North America. So it requires you to find the continent of North America, which is over here. Notice that it's very green, and green on the figure means that less than 2.5% of people are undernourished. Might not be a surprise based on what we've just mentioned. Which continent has the highest percentage of people undernourished? Again, fairly similar picture when we looked at energy. The places in the world that have the most undernourished populations, on a whole scale, are on the continent of Africa. You've got the most dark red and kind of peachy coloured countries anywhere in the world. It doesn't mean they're the only places. I mean, India, you can see, has got 20 to 34% people undernourished. Mongolia and other parts of the Middle East as well have got undernourishment in quite a lot of numbers. But Africa by far is the most undernourished continent on the planet. Again, pretty standard stuff, but worthwhile practicing these skills. Okay, now looking at fresh water consumption. So we've done energy, we've done food, and now we're on to water. The amount of fresh water available globally is limited to 3% of the Earth's water. So if you imagine, the Earth is a pretty wet place. The blue planet is called for a very distinct reason. It's covered in water. But only 3% of all that water that you see from the pictures of Earth from space is fresh water. And that means not salty. And of that 3%, only 1% of it actually is available, because 2% of it is frozen in ice caps, glaciers in places like Greenland and Antarctica. So we have very little fresh water when it comes to actually the water you see on the Earth that we can utilise. A lot of that water is stored so deep underground we can't access it. So it's not as simple as we've got loads of water, let's just drink that. The global supply of water is continuous, because the thing called the hydrological cycle means that there's always the same amount of water on the planet as there's always been. But the way the water is formed, or the form of that water at any one time, differs. So at one time there could be far more water in the atmosphere. There could be far more water locked up in ice caps. So during an ice age or a glaciated period, there is far more water locked up as ice, and therefore it's less available. In other parts of the world, with global warming going on and climate change, we are finding that actually the air around the Earth has the ability to hold more moisture at one point. So that means that water is staying in the atmosphere longer before it rains, and that means that can lead to things like drought and unreliable rainfall patterns. And the world's rivers, lakes and aquifers, they do vary. They're fairly continuous, but they do vary in terms of how much is in them at any one time. So again, just like food, just like energy, supply of water is unevenly distributed. And because the rainfall patterns vary around the world. If you've already done the weather hazards and climate change topic, you'll know that rainfall patterns vary around the world. You know, when you go north and south of the equator in sort of the tropics of Cancer and Capricorn, you find desert areas because air is sinking there. That's nothing to do with us. That is to do with the Hadley cell, and so therefore it creates dry regions, deserts. So those places probably not the best place to set up a farm that requires lots of water. But temperate regions like the UK, we experience rainfall fairly consistently year round. The equatorial rainforest, places like the Amazon and the Congo, they experience rainfall basically every single day. So the supply of water and fresh water is unevenly distributed as well. Now, most places have a rough balance. You know, there's a bit of a status quo. It doesn't mean that they have the same number of rainy days as dry days, and in the same way, some countries, some parts of the world get all their rain over a 3-month period and then none for like another 6. That is, you know, their balance. That's the way they receive it. Whereas the UK, we kind of have a more seasonal balance. But other places, obviously, like North Africa, like the Sahara, the Sahel region, they receive little rainfall. They've got high rates of evaporation because they're near the equator, so it's warm, and they have lots of what we call a water deficit all the time, not enough for their needs. So get this information down, pause the screen. I promise I won't sneeze again, and then we will do some more geographical skills using maps. Oh, sorry, I said maps, I meant graphs. So here we go, here's a graph. So if you're expecting a map, I'm sorry. And this graph is a slight difference in terms of showing global water consumption. So how we've put this kind of together is each line represents a different kind of area of the Earth. The blue line, the top one, represents the world. So that is global water consumption. You can see from 1900, our global water consumption has increased from just probably about 600 billion cubic meters per year to predicted by 2025 to be over 5,000 billion, so 5 trillion effectively, 5 trillion cubic meters of water per year. Now that's a huge increase. You know, it's nearly tenfold increase, 10 times the amount of consumption. Huge numbers. But then it's broken it down into the different continents. So what you can see is the place that consumes the most water is Asia, and they are the brown line here. Then you've got North America, so the USA and Canada, with the little peach colour. Then Europe, the orange line, followed by Africa, the green line. South America, which is just below Africa there, and then Australasia and Oceania, so this red line here, which doesn't really seem like it's changing very much. I've got an exam tip for you though. When you're looking at line graphs and the way to describe patterns on graphs, try and use the PDA technique, so the pattern, data, anomalies. Nice and straightforward. What is the overall pattern? You know, what's happening to these lines? All of these lines are kind of going one way, most of them anyway. Can you use data to evidence your pattern? So you can say, you know, global consumption is increasing, that's a pattern. Data, so it started out as being, you know, about 600 billion cubic meters in 1900, whereas it's projected to be approximately 5 trillion cubic meters by 2025. That's pattern and data. And then anomalies. Well, actually, you look at Oceania, which hasn't gone up very steadily. In fact, Oceania is barely registering on there for the entire duration of this period. So pattern, data, anomaly, great. You might be required to explain some of these patterns, but at the moment this one just says describe the trend. So pause the screen and have a go using this graph to describe the trend of global water consumption in billions of cubic meters per year. Pause the screen, off you go, and then I'll reveal an answer. Okay, so hopefully you've had a decent stab at this and you've used the PDA technique. I've written a far more detailed answer than you'd need for 3 marks, just to kind of give you kind of more scope in terms of using data, etc. So since 1900, the global water consumption has increased at a steady rate. It's nice to include a rate of increase. That's worth a mark. That's clearly identifying a pattern. It has risen from 600 billion cubic meters per year in 1900 to 4,500 billion cubic meters per year in 2017. Okay, I've gone up to a certain figure. So I've used data, pattern, data. It is predicted to continue to rise by a further 700 billion up to 2025. So I've just used more data there. Australasia and Oceania have experienced the lowest increase in global water consumption and used the lowest amount of water overall. That's kind of an anomaly. because most of the others are going up fairly steadily. The greatest increase has been in Asia, which also uses the highest amount of water overall. So again, I've identified another pattern. Loads of stuff here that you could draw from. I'm hoping you found that kind of fairly straightforward, but it's something which you can always use for graphs when it comes to analysing patterns. And you could even use this for maps. The map works the same. Is there a pattern in the spread of food, for example, global calorie consumption? Is there data on the map? Is there a key with numbers? And are there any anomalies? Are there any places like Africa which maybe have large quantities or large amounts of undernourishment? That's something that you can still apply. So this PDA technique is a really good exam skill when it comes to describing resources. Okay, so the final thing that I want to go through this session, which I know has been a very talking one, a very note-taking one with a few skills. It's not been the most interesting, but I think in terms of the content and the pattern of global consumption, it's a really important one. But this is a plenary, so just true or false based on the knowledge you've picked up this lesson. So close your book, don't look at your notes to see if you can remember any of these statistics, and I'll go through them. So, number one, developed countries are consuming up to 10 times more natural resources than those in developing countries. True or false? Okay, that one is true. Someone who lives in North America consumes around 90 kilograms of resources each day, whereas someone living in Africa consumes around 10 kilograms per day. That one is also true. It is estimated that global energy consumption will increase by 36% in the next 35 years, with Asia being one of the leading contributors to the increase. True or false? This one is false, because the answer is actually 56%, not 36%. Africa has the highest percentage of people undernourished. That one is true. And the amount of fresh water available globally is limited to 13% of Earth's water. True or false? This one is false. It's actually only 3%, 2% of which is ice. Okay, loads and loads of stats, loads of facts, but what you have got from this session is a really good introduction in terms of consumption of resources, of not just energy, but water and food as well, with global patterns of that consumption and reasons why those global patterns exist. Next lesson, we are starting to look at energy in much more detail. We're going to focus on the optional part of the paper. So remember, the paper splits into two. The first part is it talks about energy, and the second part could talk about water. We only need to do one of those two options. So we choose energy. The remainder of these lessons are going to really help develop your knowledge on that part of the paper. Thank you very much for listening today, and well done for getting through it, and I'll see you next time for another Jog Vlog.